Hi, yes, I can hear you well.
Good. So let's wait for more people. I will check homework in 2 days, and then I will publish results in Telegram chat. Also, I think on this week I will publish fourth homework, and probably it would be the last one, but I'm not sure. Maybe there would be one more assignment, but it would be like an extra homework or like not for everyone. I don't really sure would it be or no, but I know that it would be not the main homework, and if somebody don't want to do it, people can not do it. So also today we will talk about advanced techniques part 2. Especially we will explore methods to combine pre-trained models and adapters, focusing on implementation and theoretical concepts. It's a merging of models or merging of adapters. And on Friday, we will discuss this topic on the lecture with slides and instruction tuning. And next week would be the last lesson about retrieval augmented generation and agent systems. So, okay, I will share the screen and we will start. I attached this notebook here in 10th week. And if you want, you can open it and go through this notebook with me. I will show this notebook in the collab. So yeah, our goal is to understand how to merge models efficiently, reduce redundancy, performance in multitask systems. So if you have models which is good, for example, in biological sphere, and another one is good in math, you cannot train the model which will be good and in that topic and that one in the same time. You can just merge it if you have two independent models. And when we talked about machine learning, classic machine learning, we had ensembles method. It is kind of ensemble method, but not in that not in that formulation that we talked in machine learning, classic machine learning. We had some methods, for example, staking, when we had results on independence models, and then we trained the one based on that models. Here we can just merge weights of large language models, but we need to have the same configuration, like the same graph of the model. And in that case, we can merge them, for example, with interpolation or with other invest methods. And today we will discuss it deeper, how how many methods we have and how can we implement it. So the first code, it's about a simple method of merging models. Here I implemented on PyTorch library the model. We define a simple neural network and I named it a simple model with an input layers of size 10 and hidden layer of size 20 and an output layer of size 5. The activation functions used relu and we creating two instances of simple model created model 1 and model 2. I can see it here. And to simulate models trained on different tasks, we initialize model 1 weights with a normal distribution and model 2 weights with a uniform distribution here. And the state dictionaries which store the parameter of the model are saved for later use. In PyTorch, a state dictionary is a Python dictionary object that maps each layers to its parameter tensors. You know it, but I will refresh your knowledges. Also, different wide initialization can lead to model coverage into different solutions, which is useful when exploring model merging techniques. And here is the simplest way how we can merge it. The weighted merge function takes two state dictionaries and weighting factor alpha is computes the weighted average of the parameter from both models. Here alpha is set of 0.6. You can see it here. It's meaning 70% of the weights come from model 1 and 30% come from model 2. The merge weights are loaded into a new instance of simple model, resulting in a model that combines characteristic of both original models. And yeah, weighted average merging completed. We see a print of this. This technique is useful when combining models trained on similar tasks. Adjusting alpha allows control over the influence of each model in the merge result. And weighted averaging can be seen as interpolating between two models in the parameter space, potentially capturing a balance between their learned features. So merging models in the similar way, it's just interpolation. You need it's the easiest way it's to imagine a linear interpolation. So we have linear function and we need to find the middle point of our function. So here, yeah, we ran that block. Here, the lower wise merge function replaces specific layers in state dict 1 with corresponding layers from state dict 2. In this example, we replace the weights and biases of the first fully connected layer. And in model 1 with those from model 2. The modified state dictionary is loaded into a new model instance, resulting in a model that combines layers from both original models. Layer-wise merging allows for select and integration of features from different models, which is beneficial when certain layers capture task-specific knowledge. This approach is taken to transfer learning, where specific layers trained on one task are transferred to another model to leverage learned representations. And we can run it. So here is the last stage. Yeah, I see a question in the chat. Why merging only first layer? just because because we want to merge this one, and if we will see it's a simple model, so we don't need merging of second layer, because it's okay. The main nodes in intuition would be here. So in input layer, maybe if we will communicate with more difficult model, and we can choose specific layers that we want to merge, and our intuition, we can choose different layers, and they test our intuition. But here is just a hypothesis and the example how we can merge it. Okay, so in the training loop here, we generate synthetics input data X and target labels Y to simulate a training scenario. And cross-entropy loss is used for classification, and the Atom optimizer updates the model parameters. And the merge model is fine-tuned over 5 epochs, adjusting its parameters to better fit the synthetic data. After merging, fine-tuning helps the model adapt to specific task or data sets, aligning the combined parameters to improve performance. And the Atom optimizer is chosen for its efficiency, is handling sparse gradients and adaptive learning rates. So we can run it, and we see, okay, just we will wait. So we see a decrease of our loss. There is no fluctuations. It's just going down. That's good, because there is a really simple environment here, and it's like a very, very easy example to understand the intuition of merging. If you will understand that it is just interpolation, it will be more convenient for you to understand a little bit more difficult examples, which we will cover after this stage. So any questions of merging in the easiest way? Our example, which was the first one. Okay. So let's move to merge kit library. Yeah, I have here code for merge kit library, and right now I want to show you what is it and how we can use it. So it's just a repository with which we can it's really useful for our projects, because you need just create YAML file with such this information of which model you want to merge as a first model, which model you want use as a second one, and layers that you want to merge, and which method do you use. Also, you can write parameters of your usage, and then if you will import this library, like in the README, you can just write one command for using, and all the work would be in this repository, you don't need to write code for this, but you will get results of saved merging models. And I want on this stage deep a little bit into different methods of merging. We will cover it in a deeper way on Friday, but right now it would be a good practice to just talk about these methods in a short way. So yeah, we can use model soup as the main method how to merge the models. And maybe you saw this paper because it's not like a new one. It's just a way when yeah, we have a lot of models and we can merge it just in interpolation. It's really similar to our first easy example in the beginning of the lesson. But here is more difficult techniques, and they give better results than just linear interpolation. Also, you can see some options of these methods. Do they have multimodal usage or base model? And besides on these options, you can choose your own technique, which will be better on your project. So I will tell you about SLERP firstly. It's a technique used to interpolate between two models by treating their parameters as points on high-dimensional sphere. This method ensures a smooth transition between models, preserving the geometric properties of the parameter space. And we will have interpolation factor, parameter which controls the blending ratio between the base model and the target model. And if we will have interpolation factor in 0, the result is the base model. If it is 1, the result is the target model. So values between 0 and 1 yield interpolated models that combine characteristic of both. And SLERP is particularly useful when you want to create a model that balances the features of two distant models, ensuring a smooth and consistent interpolation in the parameter space. Also, we can see here, there, and okay. Also, I won't tell you about ties, but I will tell you about this method a little bit further when we will discuss adapter merging, because we will use this method. On this stage, I won't discuss there because we will not have this on adapter merging. And it's a method designed to reduce interface, like reduce interference when merged models fine-tuned on different tasks. Is achieves this by specifying task vectors through random pruning and rescaling. I mean, to retrain the performance of the original models. What is random pruning? It's randomly sets a function of the task-specific parameters to 0, effectively reducing redundancy. Also, pruning is a method, one method of the PEFT methods, which we discussed on previous lesson. Because we just set to 0 some parameters and cut it like we can cut tree also, I mean decision tree, and models like neural networks, it's not important for us. Also, what is rescaling? It's adjusts the remaining parameters to maintain the accepted output, compensating for the pruned parameters. And they will have variants. We can use their ties, as you can see, combining their with the ties method, which we will discuss further, and incorporating sign conventions to align parameters updates. And also we can use their linear, apply there without sign consensus, performing a linear combination of parameters. There is there we can use when merging models that have been fine-tuned on diverse tasks, as it helps in preserving the unique strengths of each model via minimizing interference. And also I want to tell you about path through. There is no paper about these methods, and because it's pretty simple, and I think it's necessary to tell you what is it. So pass-through method is an no operating function that allows input tensors to pass through unmodified. It's primarily used in scenarios where layers taken or where staking is performed involving only one input model. So it's useful when you want to integrate layers from different models without altering the input tensors, facilitating the combination of model components in a straightforward manner. And it's really useful to use it on real projects because it's the simplest method which you can integrate with this repository. And here I have example of the code which we can use to set up this repository, and how we can communicate with this repository. So you need to install repository here, and here I created this method because sometimes models from Hugging Face they need access from your account, so it's useful for you to log in to Hugging Face account before you will run code, because if you will not do it, maybe you will have issues. And here is an example how to integrate this repository in the code. So we define a YAML configuration that specifies the models to merge, the layers to include from each model, the merging method, and the data type. In this example, we are using a path-through merge method, which efficiently combines the specified layers without additional processing. Also, the configuration is saved to a file named config YAML. And here we defined this code lines. We use merge kit YAML repository, this command, to perform merge based on our configuration, and the flags used include copy tokenizer, ensures the tokenizer is copied to the merge model. Also, we set allow crimes, allows certain operations that might be unsafe, use with caution. And also our shard size, 1 billion in this example, set the output shard size to 1 billion parameters. And also lazy unpickle allows model weights lazily to save memory. It's really useful when you want save memory and you don't have a lot of RAM, for example, in your environment. So MergeKit is a tool designed to facilitate the merging of large language models. It allows flexible configurations and support various merging strategies, enabling the combination of models with different architectures or training objectives. Also, we discussed path-through method before, and MergeKit allows the direct combinations of specific layers from different models without additional interpolation or averaging. This is useful when you want to retain the exact parameters from certain layers of the source model. I will not run it because it would be a very long operation, and here I loaded model, and then also you need a lot of RAM in your environment to load everything correctly and to store it. So if you can use it, but it's really difficult to use in Colab, Google Colab. If you want to try it, it would be better to try it, for example, on Kaggle, I think. Oh no, there is also not enough RAM. Maybe it would be better to play with this on some cloud sites, for example, from Yandex or Sber. I'm not sure, but yeah, it's really heavy operations, and you can't load it just like you can't store fewer parameters of, for example, 7 billion model. And here I also printed example of Thais merging with this repository too, how to write it in a correct way. And right now we will go to merging LoRa adapters using Thais and Dare. And I want to tell you a little bit about these methods. So task is task interference elimination by specification. It's a method designed to address conflicts between task-specific parameters when merging models fine-tuned on different tasks. It involves specifying task vectors to reduce interference, and there is key techniques, aligns parameter updates across model to minimize conflicts. Also, there is specification retrains only the most crucial parameters for merging effectively reducing reducing. So there is parameters of that technique. It is a density, specifies the fraction of weights to retrain in the task vectors, and gamma, it controls the magnitude of pruning for large weights. So Thais is practically useful for merging models fine-tuned on diverse tasks, as it helps preserving the unique strengths of each model while minimizing interference. And in the context of model merging, tasks vectors represent the parameter update specific to a practical task. By analyzing and adjusting these vectors, Thais aims to create a merge model that performs well across multiple tasks. And by retraining only the most significant parameters, specification reduces the complexity of the merge models and helps mitigating negative transfer between tasks. So here, yeah, we have example of configuration for this method. Specify the model to be merged. The base model is Mistral, 7 billion parameters in version 0.1. And 2 additional models are included with specified densities and weights. The merge method is set to ties, indicating that the ties merging strategy will be used. Also defines the base model upon which other models will be merged. And we can see parameters. The first one is normalize, ensures that the merge parameters are normalized, and dtype. Dtype sets data type to float 16 for reduces memory usage. Entice merging density controls the sparsity of the task vectors and wide determinants that the influence of each model in the merge result. Adjusting these parameters allow for fine-tuning and balance between models. Normalizing parameters help in maintaining the stability of merge model, especially when combining models with different scales of parameter updates. And also there is Della builds open ties by introducing adaptive pruning to retrain crucial parameters during the merging process. Prioritizes retraining high magnitude changes as they are likely to be more significant, and also adjust pruning probabilities based on parameter importance, allowing for more flexible merging. Dela is dual for merging models where parameters importance varies significantly as a dynamically adjust pruning to train the most crucial parameter. So let's move for merging LoRa adapters using ties and their methods. You can find a documentation of, let me see, of the PEFT method. It's not that documentation. Yeah, here. So in PEFT library that we explored on previous lesson, we talked about adapters, and one of the feature which was integrated not like maybe 1 month ago or something like this, but not so long. So they integrated model merging of adapters, and it's useful because I told you that we can train some adapters, and it would be lighter than full fine-tuning. We can use it, and when we train each adapter for each task, we sometimes need to merge them. In diffusion models, there was pretty easy merge of LoRa adapters. And right now, it's possible to merge LoRa adapters in a text too, in natural language processing. So LoRa adapters enable efficient fine-tuning of large language models by introducing low-rank matrices into the model's layers. And merging multiplier LoRa adapters can be achieved using methods like ties and DARE. Ties addresses conflicts between task-specific parameters by specifying task vectors. and involves trimming redundant parameters, resolving conflict sign, and averaging align parameters. Here we have example of how we can merge it. Okay, let's install bits and bytes and update transform pip. It's necessary for downloading model in 4-bit. And let's load it. So we begin by importing classes from the PF and transformers libraries, which are essential for loading and managing adapters and models. The PEFT config from trained this operation. Method retrieves the configuration for the okay. 1 second. So yes, retrieve the configuration for the no robots adapter, providing details about the adapter setup. It's necessary to say that this model, if I will search it on Hugging Face, if I will open and I will go to the files and various, you can see adapter model safe tensors. It's a file for adapter model, and that means that this model was trained with LoRa adapter. If I will go to other models, for example, Quen, I would not see any files with adapters because I will see config, but not adapter config. And that means that this model was trained full without freezing parameters and editing adapters to the model. So also using auto model for casual LM from pre-trained this stage. This method retrieves the configuration for the, not configuration. This method will load the base model specified in the adapter's configuration, and the parameters when we set load into 4-bit and device may out and enable 4-bit precision loading and automatic device allocation. So we just allow our model to quantizate its weights and load it not in a full precision that helps us to save some resources and memory. Also, we load in the tokenizers, tokenizer associated with no robots and adapters is loaded to ensure consistency in text processing. And then you can see such code line resize token embeddings. That means that the model's token embeddings are resized to align with the tokenizer's vocabulary size, accommodating any additional tokens. Is this line useful when you want add tokens to the model? For example, if you want change language of generation, for example, your model was trained on English, but you want train it on Russian, it would be useful to add tokens to embedding layers of this model, because you will have tokens for Russian language, and you will tokenize text more in a short sequences, so you don't need you can show model more context length size, and you can generate your tokens more optimized, because it would be more convenient for your model to generate one token of a 3 Russian language than these 3 letters of Russian language with 5 tokens, for example. But if you will not add tokens in the embedding layers, you will get 5 tokens per 2 letters, because tokenizer was trained for English language, and because of BPE tokenizer, like bytes per tokenizer, you will have tokens for the Russian language, but it would be too long. So, any questions on this stage? Yeah, and also after resize of embedding layer, you load in NoRobots adapter is integrated into the model using PEFT model from pre-trained, specifying that adapter's name. And additional adapters SQL and copy are loaded into the model using a load adapter method, which assigned a unique adapter name. Also, maybe it would okay, yeah, I think it's necessary to say some theoretical information. Adapters are, we know what do they do, and we explored it on previous lesson. But loading models with 4-bit precision we didn't met before, I think. So it's we reduce memory consumption, enabling the deployment of large models and hardware with limited resources. This technique is particularly beneficial when working with essentially large language models. So it would be okay for us of quantize bytes of our model, and we can do it without any issues. And yeah, there are some parts of the model which we can quantize, and there are some parts of the model which we can't use. It would be not so useful to quantize some parts of the models, because quality of the model will decrease. So quantization of bytes, it's okay. Okay, let's see next code block. We especially we specified the adapters to merge NoRobots at copy and SQL, and assign bytes to each indicated their relative influence in the merge adapters. The adapter name is set to merge density to 0.2 and combination type to ties indicated to use of the ties merging method. We discussed it earlier. Also, if an adapter named merge already exists, the model configuration it is deleted to prevent conflicts. And the advised adapter method merges the specified adapter using the ties method, considering the assigned weights and density. And finally, the newly created merge adapter is set as the activate adapter using set adapter, and the model is set to evaluation model with a model point interval. And here we can test how does it works. Yes, so maybe also it's necessary to say that the density parameter controls the fraction of White's retraining of the task vector during merging. A lower density results as a sparser merged adapter, which can help in reducing the potential conflicts between adapters. And let's run the last block. So we create a list containing a dictionary that represents the user's input message, requesting an easy about generative AI, and the apply chat template here method formats the input message according to the model's chat template, adding the necessary prompts for generation. It's convenient that already Hugging Face have their own chat template, and we can use it because a few years ago engineers had to implement it by themselves. So, but now you can use done function. And also the formatted text is tokenized into input tensors and suitable for the model. The tensors are then moved to GPU for efficient processing. Also, the generate method produces text based on input, which parameters controlling aspects of the generation. Here we can see max tokens, max new tokens of 256. It limits the generation of this value of new tokens. Also, we can see in parameters to sample true. It enables sampling, allowing for more diverse outputs. And top P, I think that I told you what does it mean, but I will repeat that this parameter implements nucleus sampling, considering only the top 95% of probabilities. Yeah, and I think it is all the information that I wanted to show you. With this notebook, you can use merging of models easier because I search for information about model merging, and it's not it's in the same time it's not a new method, but also people started to implement it on the projects only maybe 6 months ago or something like this, and it's kind of new one in using it on real projects. So I think this example of code blocks would help you to use it on some tasks. And also if you will just copy blocks of this documentation, you will not get you will have some issues. But this example of using adapters and merging of adapters, you see that there are no issues and your model is working. So do you have any questions? But we will deep into all of these methods on Friday, and we will discuss it in formulas and how does it work and why.
No questions for me.
Okay, good. So if you have no questions, I think we can stop the lesson and have a good evening. Yeah, thank you for your attention. See you on Friday. And also, how I said, I will check your homeworks tomorrow or on Thursday. I'm not sure how long time would be for checking homeworks, but I will send you screens with the results.
Thank you. See you soon.
Thank you.
Yeah.
Bye.
And bye.